If you find the queen in the hive today, see her walking across the comb and laying eggs, it is very easy to conclude that everything is fine with the colony, but that can be a serious mistake. The presence of a queen is not the same as a stable future for the colony. The queen is not important only because she lays eggs. She ensures the continuity of new generations, and through chemical signals she influences the physiology and behavior of worker bees. But she is not a commander who independently controls every process inside the hive. The queen you see today may be present, alive, and active while the colony is already moving toward a problem. The amount of brood may be insufficient. The brood pattern may indicate that something has changed, or the problem may not be the queen at all. It may be related to food reserves, pollen availability, brood health, varroa pressure, or the overall condition of the colony. That is why in this lesson we will not simply answer the question of what the queen does. We will examine how her presence, reproductive capacity, and chemical signals affect the colony, but also how the workers and the condition of the entire colony affect her. Most importantly, we will learn why simply finding the queen is never enough for a professional assessment of the colony. The name queen bee often creates the wrong impression. The queen is not the commander of the colony. She does not decide which worker will leave to collect nectar, when the colony will cool the brood nest, how many bees will guard the entrance, or when an individual worker will change jobs. Most of these processes emerge through the actions of thousands of workers responding to local signals, temperature, food availability, the needs of the brood, pheromones, and conditions in different parts of the nest. Each bee responds to the information available to her, and the combined result of those individual responses becomes the organized behavior of the entire colony. The queen, however, has two central functions without which a normal colony cannot maintain long-term stability. The first is reproduction, laying fertilized eggs that develop into females and unfertilized eggs that develop into drones. The second is chemical communication. The queen produces a complex mixture of chemical signals that influence worker physiology and behavior and communicate information about her presence and reproductive condition. That is why her influence extends far beyond laying eggs. But influence is not the same as complete control over the colony. An individual worker bee lives for a limited period of time. During the active season, her life may be relatively short, while winter generations can live considerably longer. The colony, however, can survive for years. That is possible only if generations of bees are continuously replaced. During the active part of the season, a high-quality queen that is properly supported by the colony can lay a very large number of eggs each day. But the number of eggs alone is not enough for a proper assessment. We must consider whether fertilized and unfertilized eggs are being laid in the appropriate cells, how the brood is distributed, and whether the colony is producing the generation it needs at that point in the season. When inspecting a colony, it is therefore not enough to say, "I saw the queen." A far more useful question is, what do the eggs and brood tell us about her performance and the condition of the entire colony? A compact worker brood pattern that is appropriate for the season and the conditions surrounding the colony usually provides more useful information than physically finding the queen. If the brood pattern is extremely irregular, if the brood area is shrinking without a clear seasonal or nectar flow-related reason, if an unusual amount of drone brood appears, or if the colony is not producing the generation it needs, we must investigate the cause. The queen may be one of those causes, but she is not the only one. The queen communicates with the colony through chemical signals. One of the most important parts of this system is queen mandibular pheromone, or QMP, a complex mixture of pheromonal compounds produced by the queen's mandibular glands. These signals influence worker physiology and behavior and provide important information about the queen's presence and reproductive condition. Workers near the queen form what is known as the queen's retinue. They touch the queen, feed her, groom her, and come into direct contact with her chemical signals. Those signals are then distributed farther through the colony through contact and material exchange among workers. As a result, every bee does not need to physically see or touch the queen for information about her presence to spread throughout the colony. When the queen's signals change, weaken, or disappear, worker behavior also changes. If the colony loses its queen, the workers can begin raising a replacement relatively quickly by using suitable young worker larvae. But this is possible only if larvae of the appropriate age are available when the loss of the queen is recognized. The age of the larva selected by the workers can affect the developmental potential of the future queen. This reveals something very important. The colony does not depend solely on one individual. It has biological mechanisms that allow it to monitor the queen's condition and respond when the existing system is no longer stable. Another common mistake is assuming that the queen independently determines how many eggs she will lay. In reality, the rate of egg laying and the total brood area also depend on the condition of the entire colony. Workers clean and prepare the cells in which the queen will lay her eggs. They feed her and provide the conditions required for intensive reproductive activity. Young bees nurse the larvae while foragers bring in nectar, pollen, and water. All of these activities must be coordinated. If the colony does not have enough food, fresh pollen, empty comb, or young bees capable of feeding the larvae, the brood area may begin to shrink. Brood production is also influenced by the season, nectar flow conditions, temperature, colony strength, health status, and the amount of available space. That is why the queen and the colony must never be evaluated separately. A high-quality queen in a poor biological environment cannot solve the colony's problems by herself. A colony without sufficient food, under heavy varroa pressure, or with too few nurse bees cannot reach its full developmental potential simply because it has a good queen. Conversely, a very strong colony with a queen whose reproductive capacity is no longer sufficient may gradually begin to lose stability. That is why, in serious beekeeping, the queen is always evaluated within the context of the entire colony. When we open a hive, finding the queen can be useful, but it should not be the main objective of every inspection. In most cases, it is far more important to find fresh eggs and evaluate the results of her work. We look for fresh eggs and examine their position inside the cells. We assess the amount and distribution of worker brood, the presence of drone brood, and the balance between open and capped brood. We determine whether the colony is developing in accordance with the season, nectar flow conditions, and its current strength. We also compare the results of the inspection with the conditions recorded during the previous examination. One inspection provides only a picture of a single moment. 2 or more properly timed inspections can reveal the direction in which the colony is developing. We also check for queen cells or other signs that the workers may be attempting to replace the queen, preparing to swarm, or responding to her loss. But even here, we must be very careful. A poor or irregular brood pattern does not automatically mean that the queen is failing. Brood diseases, insufficient food, pollen shortages, extreme temperatures, old or damaged comb, varroa, and other stressors can all change the appearance of the brood pattern. Empty cells within the brood area can also appear when workers recognize and remove diseased or damaged brood. That is why a professional assessment never begins with the conclusion, "The queen is bad." It begins with the question, what is actually happening inside this colony? Only after we combine multiple indicators and rule out other possible causes can we make a responsible decision about whether the queen should be kept, monitored more closely, or replaced. One of the most important things a beekeeper must understand is the time delay between an egg being laid and a visible change in colony strength. Approximately 21 days pass from the moment the queen lays a fertilized egg until an adult worker bee emerges. After emerging, the young worker gradually moves through different tasks inside the hive before eventually becoming a forager. The bees you see on the frames today are therefore not simply the result of what the queen is doing today. They are the result of a process that began weeks earlier. That is why a problem with the queen often becomes visually obvious only after fewer new bees begin entering the adult population. When we notice that a colony is weakening, the cause may have existed long before the decline finally became visible. The same principle also works in the opposite direction. A colony that appears strong today does not automatically have a secure future. A large adult bee population can hide the fact that the nest is currently failing to produce a sufficiently large and healthy next generation. That is why we do not evaluate only the colony's current strength. We evaluate what the colony is producing today for the weeks and months ahead. The queen, therefore, does not control the hive like a commander. Her central role is to ensure reproductive continuity and, through chemical signals, help maintain the social organization of the colony. But we can understand her true performance only by examining the brood, workers, food resources, health, and conditions of the entire colony together. That is why a proper evaluation of the queen is never an evaluation of just one bee. It is an evaluation of the system functioning around her and of the future generation that system is currently producing. If you have not watched the previous lessons, return to the beginning of the course. In the first lesson, we explained why a honeybee colony functions as a single biological entity. In the second, we examined how a colony can survive for years, even though an individual bee lives for only a short time. In the next lesson, Lesson 4, we will explore the role of worker bees, how thousands of individual bees perform different tasks and work together to keep the entire colony alive. Follow the ETERNA System course, subscribe to the channel, and turn on notifications so you do not miss the next lesson.